All right, so here is the summary that we're going to refer back to anytime we have to transform something. So if it asks us to list out the transformation, this is what we're going to go off of. All right, so here are our notes today. Today we're going to talk about quadratic functions and their transformations. So we're going to kind of learn two things at one time. We're going to learn all these things about a quadratic. So let's go through this. The most important point of a quadratic is the vertex. So if we look at our graph that we have over here, the vertex is going to be this point right here. That vertex is at 4, 9. So 4, 9 is the vertex. Okay, the other thing that is important about the vertex is what we call the axis of symmetry. So the axis of symmetry, or the AOS, always goes through the vertex. So this has to be an equation, and this equation is going to be x equals 4. Okay, because it intersects the x-axis at 4. Then we want to talk about the concavity. So either it's going to open up or down. So we just look at our graph and say, hey, this is opening down. So we're just going to write down. So it was this one and not that one. Okay, and then again, for min and max, we're just looking at the vertex. So if the vertex is the highest point, which in this case it is, then we have a maximum, or just a max. If the vertex was the lowest point, then it would be a min. So just to give you a little visual, the max looks like that, the min looks like that. So it's all based off the vertex. All right, and then the next thing are the roots. Roots are also known as x-intercepts. So where does it intersect the x-axis? So at these 2 points, and we're only concerned with the x value of this. So different ways you can write roots. You can do the actual point, 0, 0, and 8, 0. Okay, but what I like to do is I like to just take the x value. So I use brackets, and I just write out the 2 x values. So however you want to do that. And then we're going to do domain and range. So the domain is how far left and right my graph goes, so left to right. So since this is talking about time, okay, then this is the furthest left it goes to the furthest right. It stops right there. There is not going to be any negative time. So it goes from 0 to 8 with brackets at both edges. And then the range, so we're talking about the feet now. How low can it go? So we can go this low to how high to right there. So that's 0 to 9. And again, using brackets. All right, so that's all the important parts of a quadratic. So now that brings us to our quadratic parent function. Okay, our quadratic parent function. So here's our parent function. This is something you need to memorize. This is where all equations come from with a quadratic. So all I need to do is go to Desmos, and I can enter in that equation. Y equals x squared. Okay, and there is my graph. Okay, here's my vertex. If I want more points, we just create a table, and we'll go about, let's go one more point right here. All right, sorry. So we'll use those points as a reference. So now what we're going to do is we're just going to graph that on our sheet. Okay, so we had 0, 0. Okay, that's the vertex. I know that I have an imaginary vertical line through the vertex known as the AOS. And then I have a point of 1, 1, 2, 4, 3, 9. Okay, and that's just one side of my quadratic. So now what I do is I also graph their reflection points. So it reflects about the axis of symmetry or symmetric. So there are points directly across from the axis of symmetry. And then all I do is I connect those dots. So this is what my graph looks like. So that is the graph to the parent function. Again, if you need that table, we had x values of this. And then those are the associated y values that we plotted. Okay, so we need to understand that's what the parent function looks like. Okay. So it says, given the equations, write the transformations from the parent function. So here is our parent function. It's that image right there. And we want to know what are the transformations that occurred. So remember, this is A, B, C, and D. Okay, and so we refer back to our transformations list. So A is negative. So I come over here, here's A. This is where A is negative. A is less than 0. That's a negative number. So it reflects across the x-axis. So then I come back here and I simply write reflect over x-axis. Okay, then I look at B. B is 1/4. So I come back to my transformations. I look at B. This is where B is between 0 and 1. Okay, so we have a horizontal stretch. Horizontal stretch. So then I just simply write horizontal. I can abbreviate stretch. And then I look at C. Okay, I'm adding C right here. Again, come back here. So this one's the one I look at. So X plus C right here, it moves to the left. Okay. So then we also know this goes left 2 units. And then the D value, I think all of us are really good at the D value. This is -3. So it goes down 3. But we can always refer back to that summary page if we need to. Okay. And then I do the same thing with B. This is A, that's B, C, and D. So I already have that other table kind of memorized, so I know what's going on here. So this is a vertical compression. Then, so that dealt with A. Then B is a reflection over the y-axis. And then we look at C, we're subtracting 1, so that goes to the right 1. And then D, we add 8, so we're going up 8. Again, all based off of the summary page we were just looking at. But once you memorize it, then you don't have to refer back and forth to it. All right. So then 3, we're working backwards. We want to write the equation now. Okay. And so this is how I do this. So I want to write the equation. So I know that my equation for a parent function, or sorry, not the parent function, for a quadratic function is going to look something like this, where this is A, B, C, and D. Okay, and I can go ahead and do that for both of these. So I'm putting in blanks just so you guys see, like, this is my thought process. Okay, so I have something that's vertically stretched by 2. So this is my A. So I throw a 2 out right there. Then it goes left 3. That's C. So left 3 means I add 3. It goes up 6, which deals with D. So I add 6. And then it's reflected across the y-axis. So y-axis deals with B. So this is going to be a negative right there. And so I'm done writing my equation for that. And then for part B, reflected across the y-axis, that's B, so there needs to be a negative there. Horizontally stretched by factor of 3, so this one's a tricky one. Horizontal also deals with B. So if I come back here, here's horizontal, right? And this says stretch, horizontal stretch by, and it has 1 over B. So this means that the absolute value of B is between 0 and 1. Okay, so this is the tricky part. We have to take this 3 and we have to write it as a fraction, 1 over 3. Okay, because it's horizontally stretched. And again, I just do that by the summary. Horizontal stretch by 1 over B. So we knew B was 3, so we do 1 over 3. And then move down 2, so that's out here, minus 6. And then I'm going to clean this up just a little bit because I have 2 blanks here that I didn't fill in. So we can just write it y equals negative 1/3 x squared minus 6. All right, and then here is where we can use our rules to show our transformation. And then if you need to fall back, we can always use Desmos. And I'm going to show you kind of both, right? So here we're given the parent function, f of x is what's calling it now, and g of x. So this is written in function notation. Okay, so we look at these values. This is going to be A, C, and D. And B is really like the number right here in front. That's B. So A has a value of 2. B is just 1. C is the tricky one. So usually we have x minus C. Okay, so since this is negative, we're going to make it a positive when it comes out of the parentheses. So anytime you bring it out of the parentheses, you change it to the opposite, right? So that's a full positive 4, and then D still a positive 1. So I'm first going to show you guys how to do this applying this transformation rule, and then I'll show you guys also on Desmos, okay? So here is our parent function. These are the points to our parent function. I'm going to label this as f of x, and I'm going to plot these points. So I have 0, 0, 1, 1, and 2, 4. We also know if we needed to, there'd be a point at 3, 9, but no need for, right? And there's the axis of symmetry. And then I need to also point the reflection points from the axis of symmetry. So this is my parent function. Okay. And it wants me to graph my my transformation. So it wants me to graph g of x. So g of x is this equation here. Okay, so 2 different ways we can do this. One, we can do it applying this rule. So this is the x value. Okay, all these numbers right here are the x value. And this is the original y value of the parent function, right? Then it tells us that we can multiply 1 over b times x, which there's no b because it's 1, so that's not going to affect anything. But then we add c. So all these numbers right here in this column are going to be c. So then we take c, which is 4, and we add c to all the original x values. Okay, so over here is what we're going to write there. So 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6. Then, if I'm looking at the y part, this says to take y times a and then add d to it. So all of these are going to be times the a value, which is 2. And then we're going to add the d value, which is 1. Okay, so this was a, and this was d. So we do 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3. 2 times 4 is 8, plus 1 is 9. So now our vertex is at 4, 1. I'll go ahead and do the axis of symmetry through the vertex. And then I have a point at 5, 3 and at 6, 9. So that's 1/2 of my parabola. And then I can graph the other 2 points that are across from it. And that's g of x. So if I wanted to list out the transformations, I look at how it went from f of x to g of x, and those transformations were a vertical stretch, shifted right 4 units, and up 1. Okay. If we wanted to use Desmos for this, then I could literally put in these two equations and kind of see what happened from the two. I'd really just go vertex to vertex. I'm going to show you a different way to put this into Desmos. That way you can just change the A, B, C, or D value as we see fit. So if we do f of x is equal to x squared, which is our parent function, and then if we want to adjust our values, we can say A f of b x plus c and then plus d. Okay, and you notice I can just write it in function notation, a, b, c, and d, and then I just hit enter. Okay, and these sliders, what it's going to do is it's going to allow me to change these numbers. Okay, so for instance, A was 2 in the last one, B was 1, C was a 4, and D was 1. Let's just double check that. All right. Sorry, this needs to be a minus. There we go. So I changed that to a minus. So C was 4, which is really makes it a negative 4, right? When I put in a 4 in there. So however you want to do that. If you want to leave it as a minus, or if you do a plus and make this a negative 4, then you kind of see the same difference, right? Okay. So here we can see, vertex to vertex, shifted right and up, and then it got a little bit narrower, so that was a vertical stretch. Okay, so I'm going to leave this up here so that we can adjust as we go from here on out. So it says graph this equation. Okay, so now really what I need to know is I have a negative 1/2 as my A. So if I go back to Desmos, I can change this A to negative. I can just do 0.5, right? And then we added 3. So I can just change this to a positive 3. And then we added 5 to the D value. So I can change this to a 5. And so this is what happened. So my parent function is red. Now my new function is blue. Okay, it's blue. So if I want to graph this, I need some points. Okay, notice I just clicked on those, but these points aren't nice and neat. Okay, the vertexes, but none of the other ones. So I'm just going to go here and create a table for that. And here are some nice, neat points, right? So I just grab a few. You notice like some of these aren't, so I'm not going to use that one. I probably won't use that one. But I can use 3 on one side and I should be good. Okay, so let's go. Our vertex is at negative 3, 5. So then I just come here, negative 3, 5. There's my vertex. Usually right after my vertex, I also draw my axis of symmetry, or my AOS. Then I had another point at negative 1, 3. Negative 1, 3. And then my third point was at 1, negative 3. Okay, so this is 1/2 of my parabola. And then to graph the other one, I just do mirror image of it. So there should be a point there, and 1, 2, 3, 4, and a point there. And so I've graphed that. And then this makes it easy for me so that I can graph B. So then I just go back to Desmos, and I change this A value to a 2. The C value is a positive 3, which is there, and then the D value is a positive 4. Oh, sorry, and a minus 4. So let's change that to minus 4. Here is my graph. Again, there's my vertex, and really I just need 3 points on one side. So here are 3 nice, neat points because I already have a table. So -3, -4 is my vertex. So there's my vertex. There's my axis of symmetry. -2, -2. And -1, 4. So there's half of it. And then I plot the other 2 points directly across the axis of symmetry. Okay, so really handy with Desmos. All right, so now number 6 is what we've had trouble with in the past. I have to be able to identify the vertex. So it says write the transformation from f of x to g of x. So I need to find the vertex. These 2 points are the vertices. I know that because this is where it mirrors around the y value. Okay, so what I need to know is I went from 0, -1 to -3, -2. Okay, so if you can't do this in your head, again, Desmos is our best friend here. So I can literally put in these points. So 0, -1. So I just write it as an ordered pair. And the other one was -3, -2. And there are my 2 points. Sorry, this graph's a little bit weird. So I want to know, what did I do? I went left 1, 2, 3, and down 1. Left 3, down 1. So that's what I write. Left 3, down 1 unit. So those are the transformations that occurred based off the vertices. All right. And then number 7 is going to be the tough one here. Okay, so it says write the equation. So a few things. I can come back to my graph right here and I can guess and check. So that's a possibility. So I know I really just would find my vertex. So that's at 1, 2, 2, -8. That's what it looks like. So 2, -8. So if I come back and mess with my Desmos right here, I need this graph to be down here at 2, -8. So you guys probably figure out, like, I can move it over. So that moved it to the right. And then I need to go down to -8. Okay. And then what I need to make sure, let's just make that 1. I don't know if there's a stretch or not. So I just need to make sure points match up, right? So these are my points. So I'm going to make sure like at least 3 points match up on one side. So 2, -8 matches up, right? Then it looks like I have a point right here at 1, -6. So I go check my Desmos. Oops, wrong Desmos. And I have 1, -7. So that doesn't match up. So we do know that it's been stretched because I need it to be at 6. Okay, so I need this to come up here. So we can change this. I would just change it to a 2. And there we go. Now that matches up, and I just need to make sure it goes through 0, 0 as well, which it does, right? 0, 0. Okay, so those are the points that we have. So it matches up. I just guessed and checked using my Desmos right here. So my equation could be written using these values. So I could say y equals 2 times x minus 2 squared minus 8. So this could be an answer. Okay, this is called vertex form. And then the other way I'm going to show you guys is by grabbing some points here. So this is at 4, -6, and then we have another point right here at 4, 0. Oops, that's a comma. And this is not 4, this is 3, -6. Okay, so if I wanted to generate an equation using Desmos, the first thing I would do is go to some sheets. I already have a few points in here from that one. I think I need 3, -6, and what was the other one that I'm missing? 1, -6 maybe? Yeah. 1, -6. And it's better if they're in order, but really Desmos doesn't really care. So I copy this list. This is just a spreadsheet, a Google Sheet. So I create that. I come into Desmos, and then I just paste that into there. Okay, so it creates a table where I have a list, x sub 1 and y sub 1. So these are all the points that I want included, and you can see those points. So now I'm going to tell Desmos to generate an equation. So when I generate an equation, I'm going to say y1, and then I'm going to do that little tilde, okay? And then I'm going to write the standard form of a quadratic, which is ax squared, okay? And then I need to like hit the right arrow key right here, and I want any x to have a 1 on it, so I just put 1, and then plus bx1 plus c. And so this is the standard form of an equation, and that tilde tells us to generate an equation based off the points I gave you. So here it gives us our a value, 2, our b value of -8, and then this c value. If you get scientific notation like this, just assume it's 0 right now, okay? Because it's trying its best to figure out what equation to make it closest to. So this is just going to be 0. So we just fill in 2 and -8 into our standard equation right here, okay? So the other answer that we could have could also be y is equal to 2x squared minus 8x. So I would